All right, yeah, are you seeing that?
Yes, we are. You're good to
Okay,
go.
super. Okay, so my presentation concerns the vegetation history of Florida. And what I'm going to be doing is tracing the paleobotanical record with emphasis for the most part on plant macro remains. I keep getting a message to start my video, but you're seeing it all right, is that correct?
Your video is not on. We can see your PowerPoint, but no video.
Okay, let me do this now. Okay, all right, so I'll be tracing the paleobotanical record through time and with emphasis on no analog floras, which is to say completely unique circumstances, sets of trees and other vegetation culminating in a unique association with no modern equivalents. And I'll also be then looking on the flip side at the ecological legacies, the floristic relics that exist in the current vegetation that exist as a reflection of that past and allow you to trace and understand that deeper history. It's not advancing. Okay, so the current flora is species rich, very species rich, and that floristic richness reflects geographic position, being positioned on the southeastern coastal plain, which itself is relatively species rich, as well as the state's inherent size and shape, extending from the temperate zone into tropical latitudes. That latitudinal transition is expressed in the vegetation, as you see here, focusing on the Holdridge life zone system, for which 3 bioclimatic zones have been described for Florida, spanning the more temperate moist forest through a transition zone to subtropical moist forest and into subtropical dry forest. This curving, form for the upper limits of tropical vegetation in part reflects the proximity of the warm Gulf Stream, and also the southern limits for the most part of freezing temperatures. So that's today. All right, but we want to factor in time because that's critically important. And what you're seeing mapped here are 3 different shorelines for the state of Florida, currently at B. A represents much higher sea level stands, and we can cite episodes, and I will, in deeper time when the stands were even higher and Florida was reduced to a series of islands like an archipelago. And what flora existed was present, as island communities in that landscape. And then conversely, as many of our speakers have noted, with drops in sea level connected with peaks and glacial periods and so on, much of the Florida platform was exposed. And so plants and associated fauna colonized this outer plain. To quote Ron Myers, from the late Pleistocene or early Pliocene, so about 12 million years before present, Florida has been subjected to a series of sea level changes that resulted from alternating moisture accumulation and release of continental ice sheets. Sea levels rose and fell, at times exposing the entire Floridian plateau, and at other times nearly inundating the entire peninsula, except for an archipelago along the central ridge. David Webb commented on this in terms of the biota and noted that the complex history of changes in size and shape as a result of these Cenozoic sea level cycles has frequently shaken up the biota, to quote from Dave. And on a broader scale, I'll just bring another quote to play from Dayrup and Eisner. In the late Pleistocene, North America went through a series of cold and hot climatic episodes that tumbled the regional biota about like a malaria victim's blankets, something that kind of nicely says it. The plant and animal communities, individual organisms, and so on react and have to adjust to changing climatic and sea level conditions. And this is sort of the back theme through this whole paleobotanical record. All of this implies range, geographic range for trees and other taxa. And it's important to understand, and I'm sure maybe obvious enough, that this is not a static phenomenon, that range is dynamic. And so here is a plot of sugar maple, for example, and you can see the current extent shown in dark here, but you note the little black dots, those are outliers, outlying populations, and they're a reflection, they're like the last remnants in each location, outlining the much broader range for this taxon that existed in the past. All right, and then that brings to mind then, how do plants move? They move about, adjust on the landscape through their dispersal mechanisms. So taxa like the sugar maple, also spruce and pine, have winged fruits, winged seeds and fruits that allow them to disperse using wind. Other taxa like beech and chestnut have a mutualism with mammals, including large extinct mega mammals of the Pleistocene back in the day and earlier. And so moved by that means, some are tied to bird dispersal mechanisms. So they have help one way or the other. But it's important to note too that the different plants, the different taxa, move at different rates. So they're variously moving across a landscape at a different point in time, if so, and not at the same rate of speed. In other words, the whole forest doesn't just pick up and move. The individual taxa move and move variously. And what that amounts to is no analog situations with different combinations of species present at any given window in time. And it's just important to understand that. So in addition to the novel climates that will have been experienced through past millennia, new analog communities of plants and animals are also part of that understanding, and particularly important at any given point if you're going to fully understand the situation. All right, so time. So this is one of my favorite graphs, the geologic time scale, and I'll just correct the beginning of the Pleistocene here, and then note that I'm going to begin in the Eocene. So I'm focusing on the Cenozoic, but in the Eocene, where we have some of the first plant fossils for the state of Florida. So the middle Eocene, where I'm beginning, we were underwater. So how do you have plants? You have them in terms of seagrass beds. So I'm referring to the amazing Avon Park Formation, Middle Eocene deposits in Citrus and Levy counties, and being some of the oldest rocks exposed in Florida, and revealing the presence of 2 genera of seagrasses, as well as occasional land plant leaves, suggests some terrestrial environment existed somewhere near enough for them to become incorporated in these deposits, and also algae. So an early seagrass community. The faunal assemblage reflects much the same. So sea turtles and dugongs would have been grazers on the seagrass beds. Juvenile shellfish suggest seagrass community as a nursery environment, very important situation. And trace fossils represent burrowing organisms. So the combination of plant and animal evidence points to near shore to shallow open marine environments at that time. The Oligocene is going to be kind of a drive-by for plants. Much of this time frame, Florida was still underwater, at least until quite late. There is the earliest terrestrial fauna known from the Oligocene, and inferring from those organisms, we suggest savanna to mesic forest environments were developing at that time. And moving on, to the Miocene, generally conditions were cooler and drying, and sea level was continuing to lower. Faunal evidence from Florida, at least for the mid-Miocene, suggests a fairly warm climate with seasonal moisture patterns and some dominance of savanna vegetation, grassy plains. We have a really fabulous paleobotanical assemblage from Allen Bluff in Liberty County that relates to the Miocene. This was originally studied by Edward Berry, an amazing eminent paleobotanist back in the day, and was the first to describe this ancient flora, initially as Middle Miocene, but it's since been revised to Late Miocene. And it's from the Apalachicola River bluffs. Maybe some of you are familiar with this. He worked for the most part with leaf impressions, though there are seeds and nuts and things as well. So Berry described 3 plant associations based on his findings. And one is what he called the semi-swamp palmetto break, and based especially on the abundant presence of Sabalites, the fan palm, now extinct. And notice the species name should be near and dear to people's hearts in this area. So it's the most abundant taxon. He also described a sandy strand vegetation, similar to our coastal strand today, and with some basically Caribbean elements involved, such as Pisona, Caesalpinia, and Xanthoxylum, earlier just known as Vagaria. And I know that 2 of these are bird dispersed and 1 water dispersed, so you can envision how these plants would become incorporated in this developing flora along an ancient Florida coastline. He also described a low hammock association based on a whole series of hardwoods, as you see here. So ironwood and buckthorn and elm as temperate elements, persimmon and bully as temperate to subtropical, fig and lancewood, tropical, especially pan-tropical, cinnamomum, pan-tropical. Artocarpus is an interesting paleotropical taxon, but is known from the Eocene on the west coast. And he also describes Sapaticites, an extinct taxon. Since the time of Berry, then, the Florida Museum of Natural History's paleobotanical program has been involved in new collections and revisions and better understanding of the Allen Bluff flora. And so they have described an herbaceous component in the form of 2 taxa, 2 genera of sedges, also an arboreal component, including more evidence for the fan palm, additional extinct taxa, and additional extant taxa. So this lower set, pine, elderberry, hickory, and willow, starts to be kind of familiar with what we may understand, of things today. David Webb noted that the present flora of Florida represents primarily a temperate flora, post-Pleistocene, post-ice ages, receiving additions from the tropics, whereas the Allen Bluff flora represents an endemic tropical one, gradually becoming invaded by members of a temperate flora as a result of changing climatic conditions. And in fact, during the tertiary floras of the southeastern US progressively lost tropical species and gained temperate ones. And Webb pointed out then that Allen Bluff looks like a sort of a situation in the middle of that whole progression. All right, we also have fossil woods from Miocene deposits, especially the Bone Valley Formation. So more pine, oak, walnut, the earliest evidence for walnut and the farthest extent of its range that we are aware of. And then in addition, into the Pleistocene, the next episode, we can talk about more fossil woods, another extinct palm, more oak, and walnut fruit. So just building on that evidence. With the Pliocene, the thing that I want to emphasize is this was a time characterized by especially high sea levels for much of this epoch, and some of the highest, such that, as we've been saying, much of Florida was underwater, and we were reduced to this island system for any remnants of vegetation, plant communities. So quite the opposite, back and forthing. This ancient Pliocene ecosystem exists today still in effect on our elevated sand ridges, especially the Lake Wales Ridge and the elevated sand terrain associated with those ridges. So we're looking in part at a reflection of this ancient Pliocene landscape, dominated today by a scrub ecosystem, which you may be familiar with. The interesting thing about these scrubs on these ridges is that they're huge endemisms. So they're huge numbers of endemics, so unique in all the world, plants and animals that exist on those ridges. And that's because of the great length of time that they've been able to survive on these habitat islands, these deep time habitat islands, is some more time to evolve and co-evolve without being shifted around due to sea level and climate change and so on, more stable situation. And in fact, each ridge has its own unique endemics. So it suggests, it's a study in island biogeographic theory for sure. One good example is this mutualism between Florida rosemary, the emerald moth, whose caterpillar mimics the bare twigs in the quote winter, and the foliage in the summer, the green vegetation, and also the caterpillar that is able to withstand the plant compounds against herbivory that are associated with this plant. And that all is long-term coevolution. So these are amazing reflections of that deep time Pliocene, at least beginning in the Pliocene setting. All right, then the Pleistocene, now moving forward in time, and as many of us have already noted, then now we're talking about the opposite situation of diminishing sea level and increasing exposure of the Florida platform up until the peak of the Wisconsin glaciation, as Deb Willard just noted. So again, shifts in different opportunities for vegetation to reassemble and form and colonize. So one example of a PaleoFlora for the Pleistocene is the Lycee shell pits in Hillsborough County. And this has yielded abundant pollen and plant macrofossil evidence. So for starters, what we combined, or what we described, was a northern component based mainly on the pollen, composed of hickory, sweet gum, the heath family, and hazelnut. This is the current range for hazelnut. So in other words, it's not here today. This is a reflection of change. It is, however, identified, though, from additional Pleistocene sites in Florida. So here's the Lycee shell pits. Here down in Cutler Ridge is more seeds, the nuts. So late Pleistocene, and here in our Apalachicola River area, Osceola River sites and so on, Latvis Simpson and Page Ladson. So all of this speaks to a much broader geographic range, at least in the Pleistocene, for hazelnut. And I've argued in various places, but including at these Monticello conferences, that the ability of hazelnut to be dispersed variously down the Florida peninsula was probably tied to north-south seasonal movements of mastodons and maybe other megafauna back in the day. And then lacking the fauna, it has since retreated north, plus changing climate conditions, the bioclimate. These are some of the beautiful waterlogged hazelnuts from Page Ladson, what I've spoken about before. In addition, at Lycee, pine was identified from pollen, and the Tata anatomical group are yellow pines from cones and wood. We identified Taxodium cypress, the two palms that are so frequent in our environment today, wax myrtle or bayberry, oak and willow and grape. So it's sounding very familiar here and kind of reflecting back to some of that alum bluff earlier assemblage from the Miocene. And we also identified mangroves, black mangroves, initially from root casts, but ultimately from wood as well. So the bottom line is we're seeing some subtropical, coastal zone vegetation in place at this point in time. Okay, thinking about the peak in the Ice Age conditions, this is a reconstruction very generally of the flora of Florida at that time frame. Much of it was described in a scrub or semi-desert vegetation. And it's often been equated with an African savanna, sort of described in that way. And think about mastodons and Columbian mammoth and so on as well. And with some fringing wetland or marsh vegetation around the edge and mesophytic, richer hardwood forest toward the north, especially if we went into the northwest. This is the Swanee Straits, which are discussed variously as real or not, but it would have been an environment for riparian forest along those riverine, quote, riverine wetlands. So that's very generally speaking, and much of this is based on the pollen records such as Deb Willard was already alluding to. And she also showed the Lake Tulane pollen record, which gives us a good 50 to 60,000 years worth of history. And as Deb Willard described, there's been a lot of discussion about the inverse relationship and abundance between peaks and oak and diminishing pine and vice versa. And generally this sawtooth pattern, this seesawing back and forthing in these two texts as well as others. What was the cause? And it was just recently, as Dr. Willard noted, that Eric Grimm and colleagues finally tied the seesaw effect to the Heinrich events, these glacial rafting and cooling episodes and warming intervals. So this late glacial bond cycle situation. The main reason, we don't have time to go into all the pollen, but I want to draw from those records to point out more analogous presence, more forms that stand out for their differences in range. So spruce is an obvious one, and this is Camel Lake from Liberty County back to Liberty County. There's another record, late Pleistocene in Alabama. So the two represent the most southerly extent for spruce. And I'll also point to Castanea, that's the genus for American chestnut noted here. The palynologist Eric Grimm specifies that it was Castanea dentata, American chestnut, which is one of the temperate taxa that retreated north ultimately post-Pleistocene, but was long a dominant member, huge trees of the eastern deciduous forest, like iconic of that forest, until the chestnut blight in the early 1900s and maybe overharvest of the wood and so on. There is a close relative, a congeneric of American chestnut, and that's the chinkapin, present in the state of Florida today. And this is the chestnut range. Though, as I noted, Grimm specifies American chestnut. I've wondered if they're really separable. But at any event, if it is indeed American chestnut, then we can be thinking about the broader range for that taxon before it shifted further north for the most part, post-Pleistocene. Another example is Fagus, the beech. So we know that genus from its modern range, but also from Clay County and Marion County, from 2 sediment core records analyzed by Bill Watts. So again, a broader geographic extent due to differing conditions in the Pleistocene, allowing for shifts south of otherwise very northerly components of the vegetation. And that brings me to this Appalachia region and its rich and very iconic vegetation, very species rich with a deep time history and much vaunted by botanists and archaeobotanists. All right, so this is understood as possibly a true relic forest because of the more protected status and deep ravines and so on, allowing trees to survive when otherwise they would be retreating north. Platt and Schwartz describe this flora generally as mixed species hardwood forests of northern Florida, for example, in the Mariana lowlands, Apalachicola bluffs and ravines, and the Tallahassee Red Hills regions appear unusual among southern hardwood forests, as they seem to be almost captured in time. So they have among the largest numbers of tree species per unit area in the eastern US. The Apalachicola bluffs themselves, and that brings me right back to that early alum bluff flora, has the only hammocks with endemic species of trees. And all of it is closely related floristically to the Appalachian forest well north, with several taxa that are disjunct, like those outliers with the sugar maple that I showed in the beginning, from the Appalachian mountains. And that includes fauna as well, as many as you may be aware. This forest appears to have become first established in the Miocene, and some of the reflections of that are the Florida yew and the Torreya. Now we're definitely drawing back to Alum Bluff, and with various range dynamics since in different trees and other taxa in the course of the Pleistocene with differing climate and sea level and so on. So it's a very interesting fauna. To quote further from that same article, the current restriction of certain species to ravines and other cool, moist habitats of the coastal plain and the Apalachicola bluffs reflects changes in climate that resulted in warmer, drier habitats in areas where species were once present. And some of these cooler species could endure in these protected, moist bluffs. All right, so what I've been describing in large part running through time here is the situation of no analog systems, unique forest associations, including the animals that were associated. And that's important to understand for each window in time, but also for today, for modern circumstances. Back to, again, alluding to what Deb Willard said, for forest managers and things like restoration ecology, you need to understand that ecological legacy, and again, mirroring what she said, that which window in time are you going to select, for management. It should all be really well understood. And certainly time is so limited, but Native Americans have been present for at least a good 15,000 years in the Appalachia region, and we're making use of these various biotic resources. And so again, understanding a no analog situation is certainly important to understanding their life and adaptations and presence in this area, as well as the entire region. Okay, so I guess I am stopping there. I have no idea what time it is, but that's the end of my talk.
Hey. Thank you, Lee. That was a very comprehensive presentation. I don't know if apparently we have no time for questions